So just like with real numbers, you can add, subtract, multiply, and divide. You can also do that with functions, except that there's this one other operation, and that's going to be composition. So we're going to go through the addition, subtraction, multiplication, and division. So let's first start with addition. So I'm going to have f of x is x squared plus 3x, and I'm going to have g of x is 2x minus 1. So with addition, f plus g of x, this is the notation we're going to use. What this means is add f of x and g of x. So this is f of x plus g of x. So in our example, that would be x squared plus 3x plus 2x minus 1. And we can combine these two middle ones, so x squared plus 5x minus 1. So addition of functions, that's here, just means add up the two functions, and then from there you can plug in numbers or whatever we're trying to do with the function. For subtraction, so the notation here is f minus g of x. This means take your two functions and subtract them. So x squared plus 3x minus 2x minus 1. And we're going to be really careful with parentheses here because we're trying to subtract off all of g of x. So that's x squared, 3x minus 2x gives me 1x, and then minus a negative 1 gives me plus 1. So there's my f minus g of x. The third thing we can do is we can multiply. So multiplication. So f times g of x. So for this one, just like addition and subtraction, all we're doing is multiplying the two functions. So what were our functions? X squared plus 3x times 2x minus 1. And if we want to actually multiply this out, we can. You can see it's going to be 2x cubed minus x squared plus 6x squared minus 3x. So my minus 3x came from that one. And we can combine those two middle terms, so as to get 2x cubed plus 5x squared minus 3x. So that's my multiplication. We also have division. So for division, the notation there is f over g of x. For our example, x squared plus 3x divided by 2x minus 1. So all we're doing is taking the functions, adding them, subtracting them, multiplying, or dividing them. And the more important part is going to be the notation. Now the last thing we can do with functions that you can't really do with real numbers is composition. So remember what a function is, and I'm going to use this one, this 2x squared plus 4x minus 3. That's going to be the function I'm going to look at. This says take an input and do this with it. It doesn't matter what that input is. It could have been a heart. So 2 heart squared plus 4 heart minus 3. Try something more complicated. How about f of h? So instead of the x or the heart, my input is an h. So 2h squared plus 4h minus 3. Everywhere I saw that heart or x, I just replaced it with an h. What about f of x plus h? So this is going to be 2x plus h squared plus 4 times x plus h minus 3. So take a second and make sure you understand where we got this line. Everywhere that we saw an x or an h, we replaced it with x plus h. What about f of negative x? So go back to my original one here. Everywhere I see an x, I'm replacing it with negative x. So 2 times negative x squared plus 4 times negative x minus 3. So now that we know a little bit about function composition, and we know addition, subtraction, multiplication, and division, let me give you two examples. So I'm going to let f of x be 2x minus 3, and I'm going to let g of x be x plus 1. First thing I want to know, what is f plus g of x? So remember, the addition here means add up my two functions. So 2x minus 3 plus x plus 1. And we can add this 2x and that x together. So I get 3x, and then minus 3 plus 1 is a minus 2. What's f plus g of 3? And think about what this means. This means look at the function f plus g and then plug in a 3. So if I plug in a 3, I get 3 times 3 minus 2, which is 7. Next, what is f minus g of x? So this says take f of x, subtract off all of g of x. Simplifying this a little bit, I have 2x minus an x gives me 1x, minus 3, and then that minus comes over here, so minus 1 more gives me minus 4. What's f minus g of 4? This says take the function f minus g, which we found here, and plug in 4 for x. So I'll get 4 minus 4, which is 0. What about f times g of x? So that's going to be 2x minus 3 times x plus 1. And we could multiply this out if we wanted to, but let's just leave it for now. What's f times g of 2? So this says take the function f times g, plug in a 2 for x. So I'm going to get 2 times 2 minus 3 times 2 plus 1. Let's see, 2 times 2 is 4, 4 minus 3 is 1. 2 plus 1 is 3, so I get 3. What about f divided by g of x? So f over g of x. Remember, this means take my function f and divide it by my g. Given that that's our function for f over g, what's f divided by g of 2? So that means go back to the function of f over g and plug in 2 for x. So 2 times 2 minus 3 over 2 plus 1. 2 times 2 is 4, 4 minus 3 is 1, and then on the bottom I get a third. Now what about function composition? So the notation for this. I haven't really seen this before, but this just means f of g of x. So this means f of g of x. Remember previously we said that whenever you see f of something, that just means plug that something in everywhere you see an x. So I'm trying to do f of g of x. So everywhere I see an x in f of x, I'm going to put a g of x. So that's 2 times g of x minus 3. So everywhere I saw an x in my function f, I plugged in g of x. But now we know what g of x is. It's x plus 1. What about g of f of x? So this is g of f of x. This says, look at g, so here's g. Everywhere you see an x, plug in f of x. So I'll get f of x plus 1. F of x was 2x minus 3, so this is 2x minus 3 plus 1, which is 2x minus 2. Let me do one more example with composition. Let's let f of x be 3x squared plus 2, and I want to know what is f of x. So this is really f of x, just two different ways to write it. Everywhere I see an x in this equation, it says to plug in an f of x. So that's 3 f of x squared plus 2. But we know what f of x is, so that's 3 times 3x squared plus 2 squared plus 2. So with composition, whenever it's written as f of, g or whatever, if I were you, I would rewrite that to be f of g of x, and then say that you're replacing your x with g of x.